Hello, welcome back to our organic lecture series. Today we'll be talking again about acetals, right? We talked about acetals in terms of how we can form them. But now let's talk about what we can do once we have an acetal. Is there a reaction we can do with them? Maybe go back to that carbonyl, right? So if we start with our acetal, and again, we'll work with our cyclic acetal. If we add in water in there, again, if we have a large amount of water in our reaction with our acetals, we can actually go back to our ketone and also generate our alcohol back, right? Now, for this reaction to occur, to go from this form to this one, to drive the reaction to the ketone, we need large amounts of water, large amount. Right? And this is how we kind of control the reaction. If we have a lot of water in there with our acetal under acidic conditions, we're going to drive it to the ketone. If I have the ketone plus my alcohol under acidic conditions, we can push it over this direction here, right? That's how we can control it. So it's kind of a nice reaction. It's a reversible reaction in terms of we want the acetal or we want the ketone or aldehyde, right? In this case here, we're looking at the cyclic acetal, but we could easily turn that into using the aldehyde or the ketone version of that one as well. Doesn't matter, right? So what we're going to do today is look at the mechanism of from this reaction to this form here. And we can kind of guess what's going to happen, right? It is acid catalyzed. So as we saw for one of these reactions, what's going to happen is that we're going to start with our acetal, and we use our acid. Again, what's our acid we want to use? We use a couple different acids. In this case here, we use H2SO4. Again, your acid of choice depends on your reagents and what you're using in terms of solubility, right? In this case here, H2SO4 is fine. Another one, when we form acetal, we're using TSOH, right? It's not as important, just this idea of having that acid source is the most important part as we get that, right? Again, anytime we see this acid in there, we should think about what? We have to protonate something. We're going to protonate our oxygen. Okay. Protonate our oxygen, and now that we protonate our oxygen, what's going to happen, right? Our oxygen wants to be neutral. It doesn't want to be positively charged. Something's going to happen. Look what we can do. Electrons are going to move back up to the oxygen. We're going to break that bond between the oxygen and the carbon, right? So that way, what? We generate what are we going to generate? We generate that carbocation, right? Very familiar. You've seen this before, right? We have a carbocation. What can attack that carbocation? Now we can use those weak nucleophiles to attack the carbocation. What do we got? Water. Water can attack that carbocation. So by doing that now, we've added water to that carbocation. Now we have a positive charge on our oxygen. But we don't want oxygen to be positively charged. So what's going to happen? What do you think is going to happen? Oxygen's going to be neutral. It's going to lose a proton. What do you think is going to pick up the proton? We've done this in the last two videos, right? This idea of a proton transfer, right? Proton's going to move from one oxygen to the next oxygen, right? You can imagine already which oxygen can pick up that proton. Right? By that oxygen picking up a proton, we've done two things. We made oxygen neutral, made this one positively charged, so now what? It can leave. We get to this species here, right? Now we have that positive charge on that oxygen, and we're going to do what? This is going to then leave. We want that bond to break between the oxygen and carbon, so we can generate what? So we can have that group leave, and we can generate a carbocation back on that carbon. Now that we generated that carbocation, what do you think is our last step going to be, right? How do we get to here? What do we have to do? We're going to use our best friend in organic chemistry is what? It's going to be our resonance structure. Resonance. Electrons come down. We got our resonance. And we generate a oxygen with a positive charge. And our last step is going to be what? Remember, it's acid catalyzed. It's going to generate our acid species back. Our acid is going to pull that proton off so that we can get back to our final column. Right? And so we've done our mechanism here. So if we follow this mechanism from the start with, we started with our cyclic acetal. We're going to take off the proton to generate this positive charge in oxygen, which causes electrons to break between the carbon and the oxygen. We generate our carbocation. Remember, the carbocation. Now our weak nucleophile, like water, can attack it. Water attacks. Now we generate what? Now we generate this oxygen here, so positive charge. Now we do our proton transfer. Once we generate a proton on this oxygen here, made a positive charge in the oxygen, it's going to now leave, right? And then we're going to do our resonance structure, and then we lose the proton again at the end, right? To go through this process. Very similar to what we saw before, protonation, right? We break that bond, generate carbocation, attack, proton transfer, something leaves, carbocation, resonance, right? Kind of the same process. It's a lot of the same steps we've seen before, right? All the same steps. Now we're just kind of putting them together, right? So all the same steps, right? As we go through this process. And we'll look for these ones here, right? Now we have an easy way of going from either our acetal or back to our carbonyl. We can do this for both ketones, aldehydes, right? Going from the acetals back and forth. We can do that now, okay? And stay tuned for the next video. We can look at ways of, maybe we can use this as some type of, say, protecting the carbonate, right? So we can do other types of reactions with it. We'll talk a little more about that.